Okay, so this question starts off with an R alpha method. Okay, now you should be well practiced in this. Okay, the one thing that this doesn't say is it doesn't guarantee that your alpha is going to be an acute angle. Okay, so watch out for that. It means that you are going to have to just check you have got the correct alpha when you get to that point. Okay. The other thing, as with anything with trig in it, is you need to make your decision about what mode your calculator is going to be in to save embarrassment and loss of marks. So think about that decision. Okay. Right. For part A, all right. Okay. Everyone gets R right. R, you can actually skip straight to the chase. R is always a square root, isn't it, of something squared plus something squared. So no one ever gets that wrong. To get your alpha right, okay, you have to really do it properly. So you have to expand out using the addition formula for this. We're going to get 2 sine of x minus 3 cos of x equals R times your addition formula for sine of x minus alpha, and then you need to compare the sine x's and you need to compare the cos x's, and a landmark in this process, which is always nice to see, is that our sine alpha and our cos alpha are particular values. Okay, you may not get them in this order, it doesn't matter. What matters is that when you're trying to find alpha, okay, some people like to divide by the R, which you know, and find sine alpha and cos alpha. Some people like to do the top line, or one of the lines divided by the other, to get tan alpha, making sure you do the division the right way round. Yeah, whichever one you do, okay, you're going to get alpha via an inverse tan, or it might be an inverse sine or an inverse cos, but that's only one of the 2 solutions in the possible range for alpha. It doesn't specify even a range for alpha, so that means that any value will do, but there's just going to be exactly one alpha in the range 0 to 2 pi that's going to work. So having got your first inverse tan, you then need to consider your tan graph, and we know that solutions repeat for tan every pi. Okay, so your other solution for alpha is going to be or that same value plus pi. So how do you decide which of these is going to work? Well, you know what you need R sine alpha and R cos alpha to be, and you know what R is. You've chosen the positive square root because we always do, and it says we have to. So once you've got your R and you've got a possible alpha, one of these 2, you can substitute them in and you can see what you get here. Now, you'll never be wrong unless you've done something completely wrong. You'll either be correct or you'll be correct but with the wrong sign. So if you get a minus when it should be a plus, or a plus when it should be a minus, then at that point you know that you've chosen the wrong value of alpha and you need to swap to the other one. Okay, so if alpha is not guaranteed to be in a particular range, or it's not obviously acute, then you do need to consider this every time. All right. So assuming you've got an R and an alpha, and that should be absolutely routine, we've now got to do transformations, and we've got to do the range of a function. Okay. Now the transformations, okay, this is a hence, which means that okay, this looks like our starting point, but we've got to use what we've just done, and we've already shown that this part of it, 2 sine alpha plus minus 3 cos alpha, sorry, 2 sine x plus minus 3 cos x equals this thing here. Now you'll have the values of R and alpha, so your y will be your R times sine of x minus your alpha. So these will be replaced by numbers. And then the other bit we've got is a plus 4. And we've got to do transformations. So we are taking away alpha inside, we're multiplying by R outside, we're adding on 4 outside, and you know how to turn all of those things into descriptions of transformations. And you also, I mean, check out your notes if you need to, but you also know the order of the operation. So which order we do these things in. So the sequence of thinking through your transformations is what have you done with the numbers, and have you done it inside or outside? Secondly, turn those into the words for the transformations, and either then or at the same time make sure you're setting up the transformations in the correct order. Okay. Now if you do that accurately, then you could very easily sketch the graph because you know the transformations. Okay, so by considering what happens with the graph, you know that a basic sine graph, we're transforming a graph of sine. Okay, by you know, a basic one goes up to 1 and down to -1. So you need to think about how these various transformations have been changing those maximum and minimum values, and we have then got the function defined on a complete cycle from 0 to 2 pi, so the endpoints shouldn't be in play here. Alright, so you should therefore be able to use the maximum and minimum values that you've detected from your transformations to say what the maximum and minimum values of f of x are. So remember to describe a range using f of x, so you're going to say that something is less than or equal to f of x is less than or equal to something. Hope that helps.